Now let's look at the indefinite integral of tangent to the 7th of x times secant to the 4th of x dx. For reasons that may not be completely obvious, it's helpful to rewrite this expression as the tangent to the 7th of x times secant squared dx. This is where we will use the trigonometric identity secant squared of x is equal to 1 plus tangent squared of x to replace the first secant squared of x. This lets us use algebra now. We can distribute tangent to the 7th times tangent squared of x plus 1, so we now have tangent to the 9th of x plus tangent to the 7th of x all times secant squared of x dx. The reason we wanted to do this was we now have an expression entirely in terms of tangent of x, times a secant squared of x. This is helpful because secant squared of x is the derivative of tangent of x, so we can make the substitution w of x equals tangent of x. This gives dw dx is equal to secant squared of x, so we solve dx equals dw over secant squared of x. When we plug this back in, things cancel nicely and we have the indefinite integral of w to the 9th plus w to the 7th dw. This results in 1/10 w to the 10th plus 1/8 w the 8th plus c. Then we substitute w equals tangent x back in, so our final answer is 1/10 tangent of x to the 10th plus 1/8 tangent of x to the 8th plus c.